Hi, in this video, I will be teaching you how to perform test of significant difference for two dependent groups in RStudio. When we do such test, it is important to know which of the two tests, paired sample t-test or paired sample Wilcoxon test, should we use to analyze the data. The paired sample tests are statistical hypothesis tests used when comparing two related samples, paired samples, or repeated measurements on a single sample to assess whether their population mean or mean ranks differ. These are useful in the following situation. You are a teacher and you want to check if your students learned something in your discussion. You conducted a pre-test and post-test to measure their learnings before and after the discussion. And you are a coach and you want to check if your players improved after taking some enhancement drugs. Let's discuss paired sample t-test. This test, sometimes called the dependent sample t-test, is a parametric statistical procedure used to determine whether the mean difference between two sets of observations is zero. In a paired sample t-test, each subject or entity is measured twice, resulting in pairs of observations. The R function for this test is given below. T-test function allows us to perform a t-test in RStudio. Object 1 contains the first dataset, usually the data gathered after the treatment or intervention was applied. Object 2 contains the second dataset, usually the data gathered before the treatment or intervention was applied. The paired equals true argument sets the t-test to a paired test, and the alternative argument allows us to set which of the alternative hypotheses are we considering. This can be either greater, less, or two-sided. The assumptions of the test are the following. Your variable should be measured at the interval or ratio level. Your independent variable should consist of two categorical, related groups, or matched pairs. There should be no significant outliers, and the differences between two sets of values should be approximately normally distributed. For the first two assumptions, this can be easily controlled when you plan your research instrument and your data gathering procedure respectively. However, for the third assumption, boxplot can be used to test if the data has significant outliers. Finally, for the fourth assumption, according to a technical paper published by Minitab, for as long as the sample size is greater than 20, this assumption is not that important. The paired sample t-test is robust to violations of the normality assumption. To read more about this article, the link to the technical paper is provided in the description. If the data violates any of the assumptions, we use the paired sample Wilcoxon test. This is a non-parametric statistical hypothesis test used when comparing two related samples, matched samples, or repeated measurements on a single sample to assess whether their population mean ranks differ. The R function for this test is given below. Wilcox.test function allows us to perform a Wilcoxon test in RStudio. Object 1 contains the first dataset, usually the data gathered after the treatment or intervention was applied. Object 2 contains the second dataset, usually the data gathered before the treatment or intervention was applied. The paired equal true argument sets the Wilcoxon test to a paired test, and the alternative argument allows us to set which of the alternative hypotheses are we considering. This can be either greater, less, or two-sided. The following flowchart will help you decide which of the two tests will you use for a paired sample test of significance. We first ask if the number of pairs is greater than 20. If the answer is no, then we use paired sample Wilcoxon test. Otherwise, we identify if there is at least one outlier in the difference of the dataset. We may use the boxplot to identify possible outliers. If there is no outlier, we use paired sample t-test. Otherwise, we use paired sample Wilcoxon test. Now, let's perform a test of significance for a paired sample data. In this demonstration, we will be using the mice2 dataset available in RStudio. To view the data, we must first install the Deuterium package by typing install .packages open parentheses quotation Deuterium. Highlight the code and press Ctrl Enter. Wait for it to download. And once you're done, we type library open parentheses Deuterium and enter. View open parentheses mice2. Highlight the codes and press Ctrl Enter. Notice that the dataset contains 10 paired observations from 10 mice. The weight of each mouse was recorded before and after the treatment. In this dataset, we are asked to test if there is a significant difference in the weight of the mice before and after the treatment at 0.05 significance level. Now, we will select the test that we will use for this dataset. Since the sample size is less than 20, we will choose paired sample Wilcoxon test. Then, we formulate our null and alternative hypotheses. The null hypothesis for this test is there is no significant difference in the weight of the mice before and after the treatment, whereas the alternative hypothesis is there is a significant difference in the weight of the mice before and after the treatment. To perform a paired sample Wilcoxon test in RStudio, we type Wilcox, the test, open parentheses, mice2 $, after, comma, mice2 $, before, comma, paired equals true, comma, alternative equal sign, quotation mark, two-sided. The Wilcox.test function allows us to perform a Wilcoxon test in RStudio. Mice2 $, after contains the weight of the mice after the treatment. Mice2 $, before contains the weight of the mice before the treatment. Paired equal to true argument sets the Wilcoxon test to a paired Wilcoxon test, whereas the alternative equals two-sided tells us that what we are performing is a two-sided test. We highlight the code and press Ctrl Enter. In the console window, we see the result. The V, which is equal to 55, is the test statistic, and the p-value, which is equal to 0.001953, is the probability that you will get your data assuming that the null hypothesis is true. Since the p-value is less than the significance level, which was set to 0.05, we reject the null hypothesis and accept the alternative hypothesis. Therefore, there is a significant difference in the weight of the mice after the treatment was applied. To identify which of the two is higher or lower, we compute the median weight of the mice before and after the test. We can do this by typing median, open parentheses, -2, $sign before, enter, median, open parentheses, -2, $sign after. Highlight the code and click Ctrl Enter. We can see that the median weight of the mice after the treatment is greater than their weight before the treatment. For our next example, we will use the test score dataset. The download link is provided in the description. Once you are done downloading the file, let's upload it into RStudio by typing testcore read.csv, open parentheses, file.choose, open parentheses, forward comma, header equals true. Highlight the code and press Ctrl Enter. Locate the file and double-click it. This dataset was gathered by a psychology class who performed an experiment to compare whether a recall score in which instructions to form images of 25 words were given is better than an initial recall score for which no imagery instructions were given. 30 pupils participated in the experiment, and the results are recorded. They want to test if the average recall score is higher when imagery is used. We now identify which of the two tests is appropriate for the data. Since the sample size for this experiment is more than 20, we check the box plot to see if there is an outlier present in the difference of the dataset. We can do this by typing the code boxplot, open parentheses, test score, $sign with minus test score, $sign without. Highlight the code and press Ctrl Enter. In the plots window, you will see the box plot. It appears that there is no outlier in the difference between the score with and without imagery. Therefore, we will use paired t-test. Let's formulate our null and alternative hypotheses. For this, the null hypothesis is there is no significant difference in the mean recall score between instructions given with and without imagery, whereas the alternative hypothesis is the mean recall score if the instructions includes imagery is greater than the recall score if the instructions does not include imagery. To perform a paired t-test, we type t.test, open parentheses, test score, $sign with, comma, test score, $sign without, comma, paired equals true, comma, alternative equals quotation greater. Be sure that the test score $sign with is typed first before test score $without to ensure that the test score $without will be subtracted from test score $with. Highlight the code and press Ctrl Enter. In the console window, you will see the result. T, which is equal to 10.302, is the T statistic. DF, which is equal to 29, is the degrees of freedom, whereas the p-value, which is equal to 1.673 e negative 11, is the probability that you will get the result given the null hypothesis is true. The p-value is equivalent to 1.673 times 10 to the negative 11 power, which is less than 0.05 significance level. This means that we reject the null hypothesis and accept the alternative. Therefore, there is sufficient evidence to say that the recall score is higher if imagery is provided when giving instructions, on average. In addition, the mean of the difference, which is equal to 9, and the 95% confidence interval are provided below. In practice, there are other ways to identify which of the two tests should you use for your analysis. The procedure presented here is a good start for you to practice your data analysis skills. However, I do not suggest you performing initial analysis such as Shapiro-Wilk test to test if your data passes the assumption of a parametric test. To know more about the dangers of performing initial analysis, I attach several research papers for you to read. That ends our video, and I hope you learned something. Thank you very much for watching and have a great day.